speaker is going to be Professor Siddharth, and he is Professor in Division of Neuroscience, Department of Pharmacology in Moga.
Hello, am I audible? A very good afternoon to all of you. I know it is very tough that after lunch to keep your sense organs in a very active mode, but I will try my best and I will give my best. So this is the title of my slide, that is Potential Application of Nutraceutical Guggensteron in Neurological Dysfunction. If I remove the word Guggensteron and then if we read the potential application of nutraceutical in neurological dysfunctions. Before discussing and further moving my slides, I just want to inform that there are multiple nutraceuticals and the active phytoconstituents that we studied in our lab, in our neuroscience lab. And it took a very beautiful example of this Guggensteron rather than other, because we got the very good results in our preliminary findings. So the rationale of today's presentation: are we aware, misdiagnosis, lack of therapy, and lifetime suffer. Let me give you a very beautiful example in case of autism spectrum disorder, that is, we can say normally it is autism. It is a highly misdiagnosed disorder in our Indian society, because sometimes, if there is any psychological problem, if there is any stereotypic behavior, any repetitiveness, if the child is not hearing, we are not directly goes or consult with the physician or the clinicians. We go to the other format. We following the other format to treat that child, and the treatment got delayed. Lack of therapy in the mean of there is no particular therapy for any type of neurological dysfunction. There are some specific dysfunctions that don't have any particular treatment, because the main problem in neurological dysfunction is the particular selective biomarker on which basis we can design our treatment approaches. And lifetime suffer is only not for patient as well as for family also. So these are the problems. There are various significant challenges for doctor as well as researchers. And what is happening? All of this encourage researchers to discover selective diagnostic biomarkers, and what we are doing in our lab, that in our preliminary findings, we find some very selective cellular and molecular targets which can be employed as a biomarker in the diagnosis and the treatment of neurological dysfunctions. As you know, I categorize these neurological dysfunctions in two categories: the dignitaries and the speakers and the scientists who are sitting in front of me. Some of are working on neurodegenerative disorders, some of are working on neurodevelopmental and neuropsychiatric disease like autism, OCD, bipolar, psychosis and depression. What we are doing now? A researcher at the initiation during PG or PhD, he is doing or she is doing experimental or brain disease, thesis is submitted, and there are three options. One is patent, one is library, and one is publication. Now the question is, what is next? What should be the next? I prepare a very beautiful flow diagram so that it will be easy for us that what we are missing. Suppose any researcher or any PhD scholar who is working on any brain disease, then you select a drug. Drug can be natural, semi-synthetic or synthetic. And if we replace or skip this step, that is written here is diagnostic biomarker, and directly we are targeting some cellular or molecular target, we sacrifice the animal and we conclude that this is the result, this drug is neuroprotective. But what we are missing here? We are missing two very specific samples, especially in rodents, which are highly used in neurological research, that is CSF and the blood plasma. These two samples can be treated as well as to explore the specific intervention of some specific targets. I am not incorporating all the molecular targets, I am just taking one active phytoconstituent and its study in today's presentation. So the drug and the active phytoconstituent, that is guggensteron, I take that guggensteron, as we know, it is a commiphora nucleus, antagonist of franicert X receptor, and it is very proud moment for us that guggensteron was first isolated from nature by the famous organic chemist Dr. Sukhdev at NCL Pune, and the most prominent role of guggensteron is in obesity and hyperlipidemia, and this is the paper of Dr. Sukhdev. There are two isoforms of guggensteron, one is E and one is Z. Why guggensteron? I just take this example of guggensteron. You can put any one of your them. It can be chrysophenol, it can be 4-hydroxy isoleucine, any active phytoconstituent. But why guggensteron? And why it is very active in treatment of these neurological dysfunctions? Because it having a great potential in modulating gene transcription process. It can alter various cellular and molecular targets in CNS. And yes, in our preliminary findings, strongly suggests that the protective role in motor neuron disease and autism. And less data available in specific neurological dysfunction regarding to this. Now guggensteron, which is modulating specifically in my studies mTOR, PPR gamma and JAK-STAT. These are very common pathways, STAT3. And there are three diseases where we check preclinically, we explore the potential of guggensteron not only in brain samples but by using cerebrospinal fluid and blood plasma samples. And it will be proud that there are very few researchers in India who are doing research on cerebrospinal fluid in rodents, and we are expert in the extraction and the isolation of cerebrospinal fluid from mice as well as from rats. So in brain disease, regular lab experiments we are taking some protocol drug, animal sacrifice, thesis is submitted, but our intervention is saying that guggensteron, animal not sacrificed. CSF and blood plasma is collected, an estimation of some specific markers. I just take three examples of guggensteron in multiple sclerosis, amyotrophic lateral sclerosis and autism. These are three examples where we explore these studies. I am not just explaining the whole thing, and I apologize that due to the time limit, I will just conclude the slides that what we perform. There are three molecular markers, STAT3, mTOR and PPR gamma. What we did, we just collect the samples. Simple collect the samples like blood plasma, and with the help of very sophisticated method we collect the cerebrospinal fluid. We centrifuge it and we check that during the disease progression whether these targets or the cellular molecules are being affecting or not. And we got very good results with the help of guggensteron that in disease case the targets which are altering are modulated by the guggensteron. So we got two approaches from here, that guggensteron is affecting these targets in those particular diseases, as well as when we validate and re-establish these models again and again, year and year, we found that in these samples, these particular targets are altering. These are some another examples of apoptotic markers like caspase-3, BAX, BCL2, and we also perform these markers in blood plasma samples. These are the results of STAT3 PPR gamma, and one very basic marker is myelin basic protein. I think everyone known this, because myelin basic protein is altered in neurodegenerative as well as neurosecretory dysfunctions. Now see how glucosterone is affecting the brains. These are the classic pictures of gross pathological studies, where this is the whole brain sectioning, this is the midbrain, and these are some histopathological studies where you can see that how glucosterone is affecting not only the cellular markers as well as also affecting the pathological features that are involved in the disease progression. So in conclusion, glucosterone investigated in both diseases, in neurodegenerative as well as neuropsychiatry. It is modulating the JAK-STAT and PPR gamma and mTOR, and can be used. These molecular targets can be used as a biomarker in CSF samples and blood plasma samples. And in my lab, the ongoing project by DST SOB CRG that we are doing from last 1 year, the development of diagnostic biomarkers and molecular characterization of therapeutic moieties in the prevention and diagnosis of multiple sclerosis. This is my team. This is another project that is going in my lab by MSME and in the category of idea innovation, that everybody perform the neurobehavioral experiments on rodents by using different instruments. I give you some very simple example, like if you perform the locomotor activity, you will use ectophotometer. If you want to perform learning and memory experiment, you will use Morris water maze. But the same animal will be performed on different instruments on different days. Now what was the idea? The idea is 10 in 1. This is the lab approved by the MSME, government of MSME, and this is an instrument that is 10 in 1, that with this single run, an animal will perform 10 parameters on a single instrument. And this instrument is validated, patented, and now we are going to submit the report to Government of India. Last but not least, I am very thankful to the organizer for inviting me to speak at the 5th ILCD 2022 conference, and special thanks to Dr. Acharan S. Narula Research, North Carolina, USA, for collaborating with our neuroscience group and helping us advance the scope of natural products in the study of neurological disease. And this is the sole, the credit of the result presented in my talk belongs to the hard work and intelligence of my research scholars, not me. Thanks.
Thank you, Professor Siddharth. Any question from the audience? If there are no questions, there is one.
Yeah, thank you for a nice talk. So I just wonder, if you are taking the plasma or serum samples, how does it, its relevance towards the understanding the neurological disorder, neurological disease?
Sorry, I didn't understand. Can you speak loud, please?
Is it fine now? Can you hear me?
Yes, now.
So I'm saying, how relevant is the analysis of serum sample or a plasma sample towards understanding the neurological, outcome or anything related to brain?
There are various, we are not doing like that we are selecting the targets and performing these experiments. There are clinical evidences that these particular biomarkers are altering in that particular disease progression, as well as they are validated in preclinically in various animal models, not including in rodents. They are also evaluating in, in other, the animals also. So, We are not directly taking these cellular and molecular targets in particular disease. There are evidences and the reports that in the progression of disease, these targets are altered. So we try to check whether in this model they are altering or not.
It was my general question. I was just asking generally whether this is relevant or we need to do some other things. Yeah. Thank you.
Any other question? Thank you so much.